So this is going to be a video assignment for assignment 1, the titration of arginine. So we begin by seeing the chemical structure of arginine down here at pH 0. So at pH 0, we know that the entire molecule is going to be fully protonated, and the pKa values are going to be 2, 9, and 12.5. So here we see the carboxyl group attached to the alpha carbon being at pKa2, meaning that's going to be the first one to be deprotonated. Then we see the amine here at pKa9, and the furthest amine right here, the one that's furthest away from the alpha carbon, is at pKa 12.5 and will be the last one to be deprotonated. So to get form B of the molecule, we need to begin adding moles of OH at 0.5 moles at a time. So to get from A to B, we go past pKa of 2 and we get our molecule of B. We also see here that our carboxyl group that was attached to the alpha carbon is now deprotonated, and we get the conjugate base form of the carboxyl. So we repeat the same process, adding molecules of OH, going past pKa9 because the amine group here is going to be the next one to be deprotonated, as it has the next highest pKa. So we go past pKa9 to get molecule C. Here we also see that the amine is deprotonated, and we see the conjugate base form of it. And the last molecule to be deprotonated, this amine right here, is the last one with the highest pKa value, and it's the furthest away from the alpha carbon. We go past pKa 12.5 and we get form D, and D form is fully deprotonated molecule. So to graph these molecules, we do the titration curve, and we see 3 inflection points and 3 equivalence points because there's 3 values for the pKa's. So at inflection point 1, we see that molecule A and molecule B are in equal amounts. This is because the moles of OH that are being added are half the total moles of the acid, meaning that the conjugate acid being or the acid here being the first or original molecule and its conjugate base are in equal amounts. This is also where pH is equal to pKa, as you can see on the left side of the screen here. pH and the pKa are equal. So here we are adding 0.5 moles of OH at a time until we reach 3 moles of OH. So the next step is we see the equivalence point. Here is where we will only see, where we go past pKa of 2, and we will only see the B form of the molecule. So we see all B here in this equivalence point. So here we see another inflection point where the acid B and its conjugate base C are in equal amounts. So we continue adding moles of OH, 0.5 at a time, and here we see another equivalent point where we will only see all C. And finally, we see right here another inflection point where C and D are also in equal amounts. The acid and its conjugate form are in equal proportions. And finally here, right here, at the very top, we see another equivalence point, and where we will see all D form of the molecule.